Up until now, you're probably pretty comfortable working with certain types of data, but you probably haven't noticed the distinction between what we call primitives and what we would call an object. So let's start and just remember exactly what primitive data is. A primitive is a type of data in Java that's considered the simplest form of data. It's so simple that it's stored directly in memory. These are things like ints, chars, doubles, booleans. And when you create a new variable of type int, which is a primitive, the computer separates out a box in memory with the name and the value of that int right directly there. So whenever you pass this int around, or you pass it as a parameter or copy it, you're copying the value. So you're creating a brand new version of this every time you manipulate it. This is called value semantics. Because primitives are so simple, we can do direct mathematical operations on them with the characters we're probably pretty used to using from our calculators. Things like addition, subtraction, division, and so on. There's also a number of shortcuts that you can apply directly to primitives to increase their value or decrease it or add into it. So if that's a primitive, then what's an object? An object is a much more complicated type of data because really it's a way of storing multiple pieces of related information and the different things you can do with that information under a single data type. But don't be intimidated, you've probably already been using objects. Things like strings, arrays, scanner, and array list are all considered objects. And you can notice they all start with a capital letter in Java, just to be extra clear. When you create a new variable that is of type object, like for example an array of ints, the computer separates out a box in memory for the reference to where that code is actually going to store that data. Then when you pass this around as a parameter, you're passing the reference, not the actual data. This is called reference semantics, and it's because objects are going to be so much bigger in memory, it doesn't want to keep copying them around, so you always need to be paying attention to when you're actually copying the reference to an object or the object's data itself. Because objects are more complicated, you can't do things like addition and subtraction the way you would with simple primitive numbers. But because objects come with their own behavior baked in, a lot of times you just have to look at the methods of an object to know what you can do with it. For example, if you want to know how many characters are in a string, you call the .length method. Or if you want to get the next int from the user, you call .nextInt from the scanner. Each object has its own set of behaviors that you can look up independently. Before we get too much deeper into objects, there's one thing we need to talk about, and that's the special keyword called null. Null is just a word that literally means no object. Essentially, it's the zero value for an object. Just like 0 is the zero value for int, or 0.0 is the zero value for double, null is a zero value for all different types of objects. So let's say we make a new array of strings. If we were making a new array of chars, we know that it would store the 0 value for char. But what does it store in this case when we make a bunch of strings? That's where null comes in. That's what's automatically filled into the array, meaning, hey, an object can be here, but there is none here now. This is important to know because chances are you're going to run into a very common type of exception called a null pointer exception. This usually happens when you try to perform a method on an object that is null. So for example, let's say we want to get the length of the string that's stored at the very first index of this array. There is no string there, so we get what's called a null pointer exception, like, hey, you can't call length on something that doesn't exist. Keep in mind that null means no object, not empty object. So for example, you can call .length on an empty string. Its length is 0. But there is no such thing as length of something that doesn't exist. Chances are you're going to get plenty of practice with null just by encountering errors along the way. It's just important to know that null means no object here. So if it's missing, you got to find a way to put an object there.